Hello everybody, I'm Dan. Welcome to my Java and Raspberry Pi programming tutorial series. This tutorial is about the Java MIDlet class. The first thing I'm going to do is open up my web browser, my website, pijava.com, select Pi Programming, and then go over here to the Java MIDlet class tutorial. So what is a MIDlet? Now in a nutshell, Java ME programs are MIDlets, and MIDlet is an application suite designed to live out its life cycle within the Application Management System, AMS. Now within the AMS, a MIDlet program can be in three possible states: active, paused, and destroyed. Now in the early days of Java ME, a MIDlet had a method named pauseApp and notifyPaused, but those methods have been deprecated, so we do not need to worry about the pause state anymore. So I'll briefly go over these. The way I'll do the structure of this tutorial is I'll briefly go over the constructor and methods, and then we'll compile some source code on the Raspberry Pi, and we'll run it. And then I'll go over these in a little bit more detailed state there. So, well, actually, you know what? Let's just cut right to the chase here, and let's pop right into Raspberry Pi, and we'll go from there. So I'm going to open up my Raspberry Pi. I'm already remote desktoped into it there, and first thing I want to do is do an mkdir Java, and then we'll change directories to the Java folder, and then I'll do an mkdir MIDlet demo for the name of the folder. We'll change directories to the MIDlet demo folder, and then I'll do a leafpad MIDlet demo.java. That'll be the name of the source code file there. It'd probably help if I put the pad on there. Pad. Okay. All right. Now I've got my Java tutorial open here already on the on Chromium here, but if you don't, you can pause this, open it up, and we're just going to want to cut and paste that because nobody wants to see me type all this stuff in. Just hitting the down arrow on my keyboard, by the way, to try to control how fast that goes down, and we'll just write copy and come over here and paste it. Okay, what we're going to do is we're going to compile the source code, build our Java archive, build our manifest, and build our Java application descriptor, our JAD file. And then I'm going to go over all the source code here. But the one thing I do want to go over before I do that is that we are going to be extending the MIDlet class. Okay? And of course, here's our import statement for the MIDlet is part of the JavaX Micro Edition MIDlet package there. So without further ado, let's go ahead and just save this, pop back, and we'll minimize this for the time being. So the first thing we're going to do is go ahead and compile this here. We'll close it out of that. Back to our terminal prompt. We're on the Java MIDlet folder here. We're going to type in Java C, and we need our class path to the Java ME source stuff there. So that is on the home Pi, currently logged in the Java ME folder, and then underneath there, lib and classes.zip. Okay, so that's where our stuff is located there. Well, specifically, we just need that MIDlet class there out of that classes zip file there. And of course, the name of our source code file, which is the MIDlet demo.java. Okay, so we'll compile that. We get no errors there. Now the next thing we need to do is create our manifest. MF, right? And we'll cut and paste that too off the website here, right? Here's our manifest file. And if you've been watching all my tutorials so far, all this is gonna, look rather familiar. If you're new to my tutorials, I highly suggest you watch my other ones before continuing on here. Now, notice in the manifest MF here, I've got a couple of extra line breaks there. And let's go ahead and save that. Now we're ready to build our Java archive. Okay, so we're gonna do jar cvfn. And the name of our Java archive, which is going to be MIDlet demo.jar. and then our manifest file, and finally our class file, bytecode file there. Okay. All right. Then we're going to do an ls -l, which will show us the file size of the midlet.jar. Okay. Now we're ready to build the JAD, and then we're almost done. Leafpad midlet demo.jad. Okay. And once again, we'll bring up the website here, and we'll cut and paste that in there. Okay, and there's no extra carriage return line feed or line break required here on the JAD file. All right, so let's go ahead and minimize that again here. Now, of course, we do have to record the file size in there, which is 2498 on the jar file there. And let's go ahead and save this. And now we're ready to go ahead and switch over to the Amazon management software, the application management system. So cd java me cd lib yes, no, it's in bin. I'm sleepy this morning there. Okay, so we're in the bin folder there. There's our scripts. Let's go ahead and do an ls list midlets. Okay. Oh, why am I doing an ls? I wanted to do just plain old list midlets there. So I already have this one installed here from testing out my tutorial there. So I'm just going to go do a .remove. You don't have to do this here. This is suite number 2, so we're going to remove that. Suite number 2. Now, if we got, of course, the message we're looking for, suite removed. You can ignore all these other error messages. They don't really pertain to anything there. And if we do list midlets again right now, we're going to get no suites installed. Okay. Now let's go ahead and install our midlet. I'm just going to do clear like we just came in here fresh. So do install midlet suite, and then where our Java archive is located, which is on the home. We're logged in as the Pi. That's in the Java folder and in the Midlet demo subfolder there, and the name, of course, of the Java archive. Okay. Ignore these messages here. What we're looking for is this one line, suite was successfully installed, and our ID is number 2. Okay. And now we're going to go ahead and run it, and then I'll talk about all the source code and the individual methods, constructors, so on and so forth there. So we're going to do sudo./run suite, and then of course our suite number 2 up there. And what I'm going to do is bring this aside here, and I've got my little window here on my Raspberry Pi, so you can see the LEDs blink as we execute this here. And so we'll go ahead and enter on that. We're going to get 10 blinks here out of this here. And then you'll notice we're back to the terminal prompt, right? It's not blocking or waiting or anything like that. We're right back to the terminal prompt waiting now. Okay. Now let's go ahead and come back to this window here, and I'm just going to do a leafpad midlet demo.java. I'm going to go over all the source code here now. Okay. So here is the constructor, right? And the constructor for midlet class has no parameters. Okay. Protected midlet there. So in the midlet demo there, right? Midlet. So we have no parameters in here, and basically you could see that inside of the constructor we get constructor invoked. And if we come back up here to the terminal window, right? You know what I'm just going to try to move this down a little bit so we can see everything all at once there. Okay, so the first thing displayed to the console is constructor invokes. So our constructor was invoked there. And of course, the fact that our constructor has no parameters has absolutely nothing to do with the midlet constructor having no parameters. But anyway, the Startapp method, right? Let's come back over here. This method is invoked by the AMS when the application suite enters the active state. Now this method is basically the entry point for the MIDlet. As you can see, you can put in a constructor and you can invoke some other code there too, but one thing that's for sure is that the Startapp method will be invoked. And it is an abstract method, so if you're, obviously we are extending MIDlet here, so we are required to put in the Startapp method. Okay, that's kind of why I call it the entry point there as opposed to the constructor, which definitely gets called first there. So let's talk about this next method here, abstract void destroy app, and it has this unconditional here. So this method is invoked by the AMS when the application suite is entering the destroyed state. Now, you're going to put any statements that free up resources and save program state in this method. I'm not sure why, but the unconditional parameter here always seems to return true from my experience. So let's pop back to our source code here. And of course I'm sticking the override annotations in here, and so there's the destroy app method with the unconditional, and I'll display that value to the console there, and then basically we're freeing up resources. Basically the only resource we have is the pin 18 open. Okay, so in the start of the Startapp method there, the first thing I'm displaying to the console is in Startapp method. So you can see that's the next thing that's displayed right here. Okay. Then I'm displaying to the console the get app property with single parameter. So let me pull that back over here. Let's see, I'm just gonna. So the next method that I want to talk about is the get app property, and you're passing it a argument of a string, which is the key name. And we can invoke this method to get the name of a key from the manifest or the JAD associated with our MIDlet suite. Now you'll notice this next one here, and this just returns back a string name here. And the next method is basically an overloaded version of this one here. Single parameter, 4 parameters. This returns back a string array too. Okay, but same method name, just overloaded. And I might as well go over this here while I got this up. So this is basically an overloaded version of the method above, where we can get a string array of the keys for our MIDlet suite or another application suite that is installed in the AMS. All right, so coming back here to our source code, right, invoking the getApp property and the MIDlet-vendor property, you can see it comes back with single parameter displays PyJava tutorials. Okay, I'm going to go over the next line and then we'll go take a look at the manifest so you can see what this is. The next one here, which is the 4 parameter one, we're passing it the name of the MIDlet suite, the vendor of the MIDlet suite, and the attribute, the permission. Well, in this particular case, it's like a key, right? The MIDlet-permission1, and then this is the delimiter, okay? And then I'm going through, that gives us back a string array, and then I'm just using an enhanced for loop to iterate through that string array and displaying the value to the console. So on here you can see it only comes back with, of course, the one value there, and the pipe, which I've set up as delimiter. You could put a comma or a dash or whatever you wanted, letter A for all I care, right? But we only got back one string value in our string array, single value. So, and that particular value is this right here. Okay. So if we take just a little closer look at what is in the manifest there, you'll see that the vendor, right, the MIDlet vendor is PyJava tutorials, and the MIDlet-permission1 happens to be this value right here, okay? And so that's what we displayed for the console there. So that covers those two there. The next thing is we're just basically looping through the pins and just recycling that code from previous tutorials there, where we had our looping through 10 times, displaying or setting the pin value true, which basically sets it high, turns the LED on, positive value through pin 18, GPIO port 18, pin 18, and for 100 milliseconds, and then we turn it off for 400 milliseconds. All the while we're looping through here, and you saw it blinking. So we displayed that to the console there. Okay, so now the next method that I'm going to talk about is this platform request method here. And So the platform request method would be neat, if it actually worked on Raspberry Pi, which it doesn't. It's more or less designed, say, for example, like picture like an old Nokia phone, right? And you wanted one midlet to say, you wanted your midlet, for example, to pull up like a URL or dial a phone number or send an SMS message. That's what you could do with this one here. It'll return back true if the platform request is successful. You pass it a URL string here. So we can invoke this method to notify the AMS that we'd like to make an execution call using URL. The values that can be stored in URL parameter depend upon the device that the MIDlet suite is running on. The method throws an exception if the application management system cannot handle the request. Coming back to the code here, I'm just simply trying to open up my web browser. But the Raspberry Pi operating system doesn't have the necessary configuration files to actually say, okay, what are we going to open this up with? Could we specify that, like, for example, Chromium is the default web browser? No. Windows, you have default web browsers. You can set it to Internet Explorer, Google, Chrome, so on and so forth there. In Linux-based systems, you typically don't even have that particular value or feature in there. If you want to do more research on it on your own, and maybe someone out there could get it running there. Basically, there's normally a system.config file that exists, like, for example, in Windows, and you can set your platform request command, something like, for example, // blah, 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 whatever the path of, say, for example, Firefox is, right? Then if you executed that on Windows, right, then it would go ahead and open up Firefox with that URL. However, it doesn't work with Raspberry Pi, so this particular method is basically almost worthless there. So we will get an exception here, right, because it'll be unable to process that, and we'll display to the console unable to process requests plus the message. So we do get that right here, unable to process request, and our exception message is null. Now this that's displayed to the console is just, that's produced by the application management system there. That's not anything that I was able to invoke on that there. But after that, right, now we're done with our try catch here. So we've come up to our first try, and we've got our catches, and then I've got the finally statement, which of course always executes. And inside of the, well, I wonder what I changed here to get the star on that. Hopefully I didn't screw anything up on that. Anyway, so in the finally statement here, what I'm going to do is I'm going to try to close out of our pin, because we're done with our for loop where we're blinking the LED, so there's no point in keeping it open. So what we're going to do is invoke the pin.close method, and then I'm going to invoke this notifyDestroyed method. So let's talk about the notifyDestroyed method last here. Last but not least, very important. So it's a void, right? And notifyDestroyed. We can invoke this method to notify the application management system that we would like to destroy our MIDlet suite. Now, when we invoke this method, the AMS will not invoke the destroy app Boolean unconditional method, so plan accordingly. Okay. You may or may not remember back in when we ran this there, and it just returned back to the prompt without blocking, right? It basically, the notifyDestroyed method notified the AMS that, hey, we're done. There's no need to sit there and wait for anything or anything like that. We are absolutely done. So it just went back, and AMS said, okay, boop, boop, you're done. I can run some other suites now or do something else. There's no point in waiting. So in our destroy app method, which would get called by the AMS, for example, if the user hits Control-C to break out of it, that would then tell our program that we need to free up resources or save system state or whatnot. So I essentially have the same code in the destroy app method as I do in the finally, right? Which would then display in destroy app unconditional and destroy called closing GPIO pin. As you can see, we got the closing GPIO pin, which was up here, not destroy called closing pin, right? So we didn't get any of this method, never got called. So if we come up here and we just comment out this notify destroyed here, hopefully I didn't, all right, let's go ahead and save this, recompile it, and run it again there, and you'll see that it'll block there. So let's come back up here. Oh, and what I'm gonna do is hit the up arrow on my keyboard until I get back to the Java C command. We'll recompile that. Hit the up arrow again until I get back to the jar command. Hit the up arrow again until I get back to the ls-l, and finally hit the up arrow again until I get back to the JAD there. So our file size now is 2463. So we'll change that to 2463 and save that. Come over here to our AMS window here and do a /remove, and we're removing suite 2. And then I'm gonna do some up arrow keys, and we say the suite removed, ignore those other errors, they mean absolutely nothing. And then we're gonna up arrow until we get to the install MIDlet suite again. Okay, and I'll do clear, and then I'll do sudo, and then we'll run suite, and we're gonna run suite number 2. And we got our little blinking LED 2 there as well. Okay, now you notice how we've got to our closing GPIO pin. So back here to the source code, right? You can see pin close, closing GPIO pin. We did no notify destroyed, so the AMS is just sitting there, just blocking, waiting for something else to happen from our application, which is never going to happen because it's done. So the only thing that can occur now is we can hit Control-C, and that will, of course, break out of that'll exit it, right? And after we hit Control-C right there, you can say in destroy app, unconditional equals true, right? So now you can see the destroy app there, and I just displayed the value of the parameter unconditional. It always seems to come in true. Not sure why. And then we see destroy called closing GPIO pin, right? Which is right there. And then of course our MIDlet basically terminates at that point in time. So that's really about all there is to it there. I'm gonna go ahead and close out of this, close out of that, and minimize this, and move that over there, close that, and leave you guys with some final thoughts here. So, you know, at this point, you should have a fairly good understanding of what a MIDlet/MIDlet suite is and what it is comprised of. Additionally, you should now also be familiar with how the AMS registers, controls, and manages MIDlet suites. If you feel somewhat unsure of how either the AMS or MIDlet works, please review all of my previous Java ME Raspberry Pi tutorials. Now that I've covered the AMS/MIDlet topics, it's time to move on to controlling more hardware and using the GPIO pins. That concludes this tutorial. Thanks for watching.